now understand chemical properties of alkanes. The first one is substitution reactions. As an example, chlorination of methane. The step 1 is CH4 plus Cl2 in presence of light gives CH3Cl plus HCl. Step 2 is CH3Cl plus Cl2 in presence of light gives CH2Cl2, that is dichloromethane plus HCl. Step 3 is CH2Cl2 plus Cl2 gives CHCl3, which is trichloromethane. And the step 4 is CHCl3 plus Cl2 in presence of light gives CCl4, that is tetrachloromethane. Mechanism of the reaction is given by: the first step is initiation step. The reaction is initiated by homolysis of chlorine molecules in the presence of light or heat. The Cl single bond Cl bond is weaker than the C single bond C and C single bond H bond, and hence is easiest to break. Consider the reaction Cl single bond Cl in presence of light gives 2 chlorine free radicals. The second step is propagation step. Chlorine free radical attacks the methane molecule and takes the reaction in the forward direction by breaking the C single bond H bond to generate methyl free radical with the formation of HCl. The reaction is CH4 plus chlorine free radical in presence of light gives CH3 free radical plus HCl. The second step is methyl free radical plus chlorine in presence of light gives CH3Cl plus chlorine free radical. Two such steps given below explain how more highly halogenated products are formed. Consider the reaction CH3Cl plus chlorine free radical gives CH2Cl free radical plus HCl. When CH2Cl free radical reacts with Cl2 gives CH2Cl2 plus chlorine free radicals. The last step is termination step. The reaction stops after some time due to consumption of reactant and or due to the following side reactions. The first reaction is Cl free radical plus Cl free radical gives Cl2, and methyl free radical plus methyl free radical gives C2H6, that is ethane, and methyl free radical plus chlorine free radical gives CH3Cl. Though in CH3Cl the one of the products is formed but free radicals are consumed and the chain is terminated. The second reaction is combustion reactions. Alkanes on heating in the presence of air or dioxygen are completely oxidized to carbon dioxide and water with the evolution of large amount of heat. Due to the evolution of large amount of heat during combustion, alkanes are used as fuels. During incomplete combustion of alkanes with insufficient amount of air or dioxygen, carbon black is formed, which is used in the manufacture of ink, printer ink, black pigments, and as filters. Consider the reaction CH4 plus O2 due to incomplete combustion gives C, that is carbon, plus 2H2O. The third reaction is controlled oxidation. Alkanes on heating with a regulated supply of dioxygen or air at high pressure and in the presence of suitable catalyst give a variety of oxidation products. Consider the reaction 2CH4 plus O2 in presence of Cu at 523 Kelvin and 100 atm pressure gives 2CH3OH, that is methanol. And the reaction CH4 plus O2 in presence of MO2O3 and heat gives HCHO, that is methanol, plus H2O. And also the reaction 2C2H6 plus 3O2 in presence of CH3COO whole twice Mn gives 2CH3COOH, that is ethanoic acid, plus 2H2O. Ordinarily, alkenes resist oxidation, but alkenes having tertiary hydrogen atom can be oxidized to corresponding alcohols by potassium permanganate. Consider the reaction CH3 whole thrice CH, that is 2-methylpropane, in presence of KMNO4 gives CH3 whole thrice COH, that is 2-methylpropane 2-ol. The fourth reaction is isomerization. Normal alkanes on heating in the presence of anhydrous aluminium chloride and hydrogen chloride gas isomerize to branch chain alkanes. Consider the reaction CH3CH2 whole 4 CH3 in presence of anhydrous AlCl3 or HCl gives CH3CH3 single bond CH2 whole twice single bond CH3 plus CH3CH2 single bond CH3 single bond CH2 single bond CH3, that is 3-methylpentane. The fifth reaction is aromatization. Normal alkanes having 6 or more carbon atoms on heating to 773 Kelvin at 10 to 20 atmospheric pressure in the presence of oxides of vanadium, molybdenum or chromium supported over alumina get dehydrogenated and cyclized to benzene and its homologous. This reaction is known as aromatization or reforming. Consider the reaction CH2 single bond CH2 single bond CH2 single bond CH2 single bond CH2 in presence of Cr2O3 or V2O5 or MO2O3 at 773 Kelvin or 10 to 20 atm pressure gives benzene. The sixth reaction is reaction with steam. Methane reacts with steam at 1273 Kelvin in the presence of nickel catalyst to form carbon monoxide and dihydrogen. This method is used for industrial preparation of dihydrogen gas. Consider the reaction CH4 plus H2O in presence of nickel as catalyst gives CO plus 3H2. The seventh reaction is pyrolysis. Higher alkanes on heating to higher temperature decompose into lower alkanes, etc. Such a decomposition reaction into smaller fragments by the application of heat is called pyrolysis or cracking. Consider the reaction C6H14 at 773 Kelvin can give C6H12 plus H2 or C4H8 plus C2H6 or C3H6 plus C2H4 plus CH4. Pyrolysis of alkanes is believed to be a free radical reaction. Preparation of oil gas or petrol gas from kerosene oil or petrol involves the principle of pyrolysis. For example, dodecane, a constituent of kerosene oil on heating to 973 Kelvin in the presence of platinum, palladium or nickel, gives a mixture of heptane and pentene. Consider the reaction C12H26 in presence of platinum or palladium or nickel at 973 Kelvin gives C7H16 plus C5H10 plus other products.